So what we're going to look at now is section 7.2, and this is what we have what are called rational exponents. Rational, you can think of it as meaning ratio or a fraction. So this is an exponent that's not a whole number, it's not an integer, it's a fraction. So let's say we have something like this. A little better pen there. So we have 7 with 1/3 as an exponent. Make this a little more exponent-like. So what does this exactly mean? Well, what we can do is let's cube both sides. So we raise both sides to an exponent of 3. Now, if you recall from your rules for exponents, this one we're going to distribute as an exponent. So we're going to multiply the 3 into 1/3. Now this will just be x cubed. And this is going to give us 3 times 1/3 is just 1. Or we'll have 1/3 times 3, or x cubed is equal to 7 to the 1, or x cubed is equal to 7. Now let's think about this x cubed. X cubed is x times x times x. So it's some number that if we take 3 of them, multiply them all together, we get 7. So whatever this x is, it's going to be the cube root of 7. It's some number that, again, if we have 3 copies of them in total, and we multiply those 3 together, we get 7. So x is the cube root of 7. We just haven't identified which number this was. For example, if this was 8, we would know what x would be. What number, if you take 3 of them and you multiply them together, you get 8. Well, that means the cube root of 8 would be 2, because we know that this would be 2, 2, and 2. So the cube root of 8 would be 2. Now, we don't know the cube root of 7. That's a whole other conversation. But let's keep an observation here. X and x. Well, x seems to be equal to 2 different things, but it isn't. What this is actually saying is that the cube root of 7, whatever number that is equal to this 7 to the 1/3. Well, that's interesting, because what this says is this. Rational exponents, where you have a 1 over some other whole number, this is going to mean a root. And so what we get is this. A to the 1 over n is equal to the nth root of a. So exponents that are fractions, like this, 1 over a whole number, that's just another way of talking about the root. So what does this mean? Well, for example, let's say we have the square root of 4. Now, the square root of 4 means there are 2 numbers that multiply the 4, and they're the same number. A number times itself gives you 4. So what is this number? Well, it's 2, because 2 times 2 gives you 4. But because we're talking about 2 copies of the number 2, we can write this as really the second root of 4. But this means we can write this as 4 to the 1/2. So roots are rational numbers of this type. So let's do some examples here. So let's say we have 100 to the 1/2. Now remember, we're going to use the fact that 1 over n implies the nth root. So this means 100 to the 1 over 2 is the second root of 100. And as we've seen before, that's just the square root of 100. Square root is just with that number not written, but it means the same thing. Two numbers that multiply, or the number, two of the same number multiplied together to give us 100. Well, 10, because 10 times 10, there's two 10s. They give you 100. So that means our answer is 10. Well, let's take another one. Well, let's say we have this. Now, again, we're going to use the fact that a to the 1 over n is the nth root of a. So this means negative 64 to the 1/3 is the third root of negative 64. So what's the third root of negative 64? Well, turns out negative 4 times negative 4 times negative 4 gives you negative 64. So the third root is negative 4. Let's see. So let's say we have something like this. Well, again, we're going to use the fact that a to the 1 over n is the nth root of a. Now, in this case, a is the entire thing here in parentheses. So this means the fifth root of 2x y cubed. All right. Let's see what else. Now, what if you have something like this? Now, this looks like negative 81 to the 1/4. Hold on. Remember with exponents, when we don't have parentheses that around the negative and the number, we think of the negative being outside of the calculation that uses the exponent. So we think of it like this. And then we follow PEMDAS. Exponent, then the multiplication. So the fourth root of 81. Well, it turns out three times 3 times 3 times 3 is 81. So that means the fourth root is 3. And so -3 turns out to be your answer. So that's one way of approaching it. Now let's make this a little more complicated. We could do this. Let's say we have something like this. Now, what do we do here? Now, what we've looked at so far is a to the 1 over n. But we've always had a 1 in the numerator. Well, now we don't. Well, there is a way we can kind of cause a 1 to be there. We can rewrite this as 1,000 to the 1/3 times 2. So we can treat it like we have 1,000 to the 3rd, and then we're squaring whatever that turns out to be. Now, 1,000 to the 3rd is the cube root of 1,000. Now, what's the cube root of 1,000? Well, what number, if you have 3 copies of it in total, if you multiply those copies together, it gives you 1,000. Well, 10 times 10 times 10. So that's cube root is 10. And then we square the 10 and we get 100. Now, what if we did this differently? Let's say we did so alternately, let's say we did this. Let me check something real quick there. Okay, so you can use this apparently to Professor Google, or with some help from Professor Google, you can use this word synonymously with alternatively. Just wanted to double check that. Anyway, moving on. Alternately, we can treat this as 2 times 1/3. Because remember, multiplication is commutative. You can switch the order around. So this will give us 1,000 squared, and then we take the cube root. Now, one thing to keep in mind in this is which one we do first. It's going to turn out it's not really going to matter. Now, there is maybe something to sort of keep in mind here. If you do want to make sure that if you take your root first, that if you do choose to take the root first, like we did last time, you're going to get a real number. You're not going to get something that's not a real number. So that is a concern to keep in mind. So last time, of course, we were working with the cube root, and cube roots, you doesn't really, you have to worry about that. You can take the cube roots of positive and negative numbers. But let's say we go this alternate route. Another thing to keep in mind is I got to deal with 1,000 squared. 1,000 squared is 1,000,000. So now I got to take the 3rd root of 1,000,000. So in this example, both approaches are valid. We don't accidentally take the root of a negative number. But we do have to be careful here that might be doing something that's harder than we realize. So what's the 3rd root cube root of 1,000,000. Well, it turns out that 100 times 100 times 100 equals 1,000,000. So that means the cube root of 1,000,000 is 100. So something to think about with these is you can do, say, squaring 1,000, get 1,000,000, and then take the cube root of 1,000,000. Or you can take the cube root of 1,000, which gives you 10, square that 10, and you still get the right answer, 100. So different approaches can maybe make it easier. Could be easier depending on which approach you use. So let's see. So to summarize what's going on here, if you have a to the m over n, you can treat this one of two ways. You can calculate a to the m first, and then take the nth root. You could do that like we just did. Or you could take the nth root and raise that to the power of m. And there's a big warning here, though. Provided and the same thing here. Provided that the nth root of a to the m is real. So provided that you can take these roots, you can use this approach. So let's do some examples. So I'm going to check something real quick here. I just want to make sure my camera's recording correctly. So I'm going to pause for a second, and then I'll start into the examples. I want to make sure I'm not getting anything caught off here in the cut off here in the top.